Welcome everybody back to the second part of Trig Basics, where today we're going to be reviewing the secant, cosecant, and cotangent functions, as to the first video where we reviewed the sine, cosine, and tangent functions. So allow us to begin. Based on last video, we said that we're going to be discussing the relationship between the six functions with one another. As a review, let us redefine what sine, cosine, and tangent are. Sine is, by definition, the opposite side of a right triangle over the hypotenuse side of a right triangle, whereas the cosine is the adjacent side of a right triangle to the hypotenuse of the right triangle, and tangent is the opposite side of a right triangle over the adjacent side of a right triangle, which, to note, is relative to the given angle of sine, along with its only circumstance of existing within a right triangle and no other shape other. So let us draw our right triangle as a reference to use. It's about good. And let us label our angles. Let us label our angles. Let us just scroll down a little bit. And mark their sides correspondingly. And before we move on to the cosecant, secant, and cotangent functions, let us just see as a recap what these sine, cosine, tangents look like. So for the sake of time, I'm going to do just a few examples for each one, just for your understanding. If you still don't understand, please do consider checking out the first video where I explain sine, cosine, and tangent in depth and with examples orated step by step. So let's do sine of A. Sine of A. Let's do cosine of A and tangent of B. Cosine of A, tangent of A, sorry. And you could find cosine of A, cosine of B, sine of B, and tangent of B correspondingly to the ways we do it for sine of A, cosine of A, and tangent of A. Based on our definition, we know sine of A is opposite over hypotenuse relative to the given angle of A. Therefore, from this triangle and this graph here, we can see that the opposite side of angle A is side A, with the hypotenuse here drawn in yellow, side length C. So, let's scroll down, and staying true to our definition, write down the ratio of A over C. Likewise for cosine, it is the adjacent side relative to angle A, which is drawn in green right here, side length B. And with the hypotenuse remaining the same as side length C, we write the ratio of cosine A as B over C. Now for the same thing for tangent, we apply and stay true to our definition of tangent, and as always encourages you to pause the video and attempt to find this out on your own. The definition of tangent is opposite of a hypotenuse relative to angle A in this circumstance, which the opposite side, as mentioned before, is side A, with the adjacent side being side length B as labeled here in green. Therefore, tangent of A being A over B. Now we have a solid understanding and a background of sine, cosine, tangents within right triangles. Let us move on to secant, cosecant, and cotangents. Secant, which is spelled S-E-C-A-N-T, cosecant with a C-O in front of it, cosecant, and cotangent can be abbreviated as S-E-C for secant, C-S-C for cosecant, and C-O-T for cotangent, respectively, which I'll be using their abbreviations for the remainder of this video for the sake of simplicity. One thing to note here is the relationships of secant, cosecant, and cotangent to sine, cosine, and tangent. Sine is the reciprocal, which I can abbreviate REC, of cosecant. Cosecant, which is CSC. Cosine is the reciprocal of secant, where tangent, from order of elimination, as cotangent. Now, you might be wondering what the co in front of cosine, cotangent, and cosecant mean. Well, the abbreviation of co, CO, stands for complementary. And we'll be exploring why they'll be complementary in future videos where I explain in depth about the relationships, in further deepened relationships between sine, cosine, tangent with cosecant, secant, and cotangent. Before now, you just need to understand this concept right here, that sine is the reciprocal of cosecant, cosine is the reciprocal of secant, and tangent is the reciprocal of cotangent. So, with this in mind, let us define what secant, cosecant, and cotangent are. We know that sine's definition is opposite side over hypotenuse side relative to its given angle. So, with cosecant should be equal to 1 over sine. And as noted earlier, we know that sine is A over C, which was equal to C over A. This, my friend, is cosecant of A, as this would be sine of A. And likewise, for cosecant of B, we know that cosecant of B is 1 over sine B, which is equal to 1 over B over C, which is equal to C over B, which we can generalize as cosecant is equal to 1 over sine, which is equal to 1 over opposite over hypotenuse, which is equal to hypotenuse side over opposite side of the relative to the given angle, of course. Likewise, I encourage you to pause the video to find out the relationships and the definitions of cotangent and secant, respectively, as like this example. So, next up, let's move on to secant. Secant is equal to 1 over cosine, which definition is adjacent over hypotenuse, which is equal to hypotenuse over adjacent. Then we have cotangent as 1 over tangent from this right here, knowing that sine is the reciprocal of cosecant, cosine is the reciprocal of secant, and tangent is the reciprocal of cotangent, respectively. Cotangent is 1 over tan, which is then equal to 1 over opposite over adjacent, relative to tan's given angle, which then can be rewritten as adjacent side over opposite side. So now we have defined all 6 trigonometric definitions and functions that are tangent, cotangent, tangent, cotangent, secant, cosine, sine, and cosecant. We'll be exploring how these 6 trigonometric functions can be used with further depth and relationships with the magic hexagon, which I'll be explaining in the next video. Hopefully you have learned something new, and this will be all for today.